Chapter 5, we're going to talk about the integumentary system, or skin. So in today's lecture, we'll talk about the structure and functions of integuments. We'll talk about the structure of epidermis and dermis, as well as the subcutaneous tissue, or hypodermis. We'll talk about some of the other structures derived from skin, like hair and nails and sweat glands and oil glands, and other types of sensory receptors. We'll talk about how skin is repaired and regenerated, and then maybe talk a little bit about aging of skin. Now, we know that skin is the largest organ in our body, and it serves as a protective barrier because it basically surrounds our entire body and just encases us within this sort of layer of tissue, right? So skin is protective in that regard. Now, it also protects against other things like water loss. We know that skin is made of, in part, keratinized stratified squamous epithelium, and we learned that keratin was a really strong and waterproof type of protein, so that our skin is waterproof, right? You can't absorb a significant amount of water in your skin, nor can you lose a significant amount of water through skin, unless you're sweating, right? So it's protective in that regard. Skin's also involved in temperature regulation. You know, like we know that if you're too hot, you sweat. If you're too cold, you can shiver. But what's interesting too, if you're too hot, you can also divert blood flow to skin. So if you're too warm, you can take more blood, bring that to skin, and that way you can help dissipate some heat away from skin in that regard. So skin's involved with body temperature regulation. It also has some functions in metabolism because skin produces vitamin D. We know this. Turns out vitamin D is a hormone, and this hormone's involved with calcium metabolism. And so we'll get back to that later. Skin's also involved in immune defense. You know, it's a protective barrier, and it's one of the first line of defenses against, you know, the external world in our bodies. So that if you get a cut in skin, there's already a lot of immune cells within skin that help protect against infection. So it's a really effective barrier in that regard. And so what's interesting too, guys, is that in skin, in the secretions, those also have like antimicrobial products. So in sweat, that has antimicrobial products. In oil, that has antimicrobial products. So it prevents bacterial growth to some regard. In fact, I just saw a headline yesterday. It was saying that apparently, like in beards and other body hair, now it is rich in bacteria because it's a place where bacteria can survive. But they're also suspecting that in body hair, not just beards, you know, people pick on beards, I guess, but like, you know, I'm just talking that because I have one apparently. But like other body hair, you might find bacteria that could be a good use of an antibiotic, right? We get antibiotics from bacteria because there are antibiotics that bacteria make, right, to fight other bacteria because they want to have their nutrients and not have other bacteria use them. So they're suspecting that you might be able to get antibiotics from bacteria that we don't already know about, like other bacteria maybe that grow in our body hair. So something to investigate. It's pretty cool. Maybe like the next generation of antibiotics could come from a bacteria from like some hipster's beard, right? So who knows? So we know that skin's also involved in sensory reception. So we can use our skin to feel, right? Like our skin can be used to feel temperature, pain, pressure, vibration, touch, which is very fine tactile sense. And it's not just your hands. Like you can use other parts of your skin to feel as well. But there are certain skin areas that are more sensitive than others, right? We know that our hands are very sensitive. We know that the skin of our face is very sensitive and the skin of our lips. But there are other insensitive skin areas too, right? Like the skin of your elbow, right? Super insensitive. You know, I can pinch that skin of my elbow really hard. It doesn't even hurt, right? Or the skin of your back is also pretty insensitive, right? So this difference in sensitivity comes from the fact that different patches of skin have different proportions of nerve endings there. Like you can find a lot more nerve endings in your hands versus the skin of your elbow. And that's just due to our anatomy. So we'll talk about that today too. Our skin is also a decent excretory organ. Excretion is the elimination of wastes. But you can eliminate wastes through skin secretion. So skin secretions like sweat and oil, some wastes are eliminated through skin. Not a significant amount, but some are. Like let's say if you have some urea, like nitrogenous wastes, that can be excreted by your skin. Like if your kidneys can't get rid of all of it, your skin can take over and help eliminate some waste. So there is some truth to when like hippies say like sweating out the toxins, right? Like I'm gonna go sweat out those toxins. There is a little bit of truth to that. Now, are you going to like totally detoxify your body by sweat? Probably not, okay? But it might help a little bit. So it's kind of interesting. Integument is skin, and it's the largest organ. And you guys ever see the mean tweets on Jimmy Kimmel? I watch them on YouTube. They're freaking hilarious, man. Basically, celebrities reading their own mean tweets about themselves. And there's one where Larry King was on there, you know, the old the news pundit, and somebody tweeted, if you took all of Larry King's skin, ironed it out, you can make enough coats to give to every cold child in America. I was like, oh my gosh, that's intense. Like, and then even Larry King was like, ooh. And he's reading his own tweet, right? So it's kind of funny. But apparently he's got a lot of loose skin, you know. Well, it makes sense. It's your largest organ. And there's two main layers to skin. We got epidermis and dermis. In epidermis, it's the keratinized stratified squamous epithelium. So it's avascular because it's an epithelium. In dermis, that's the connective tissue layer, and it's made of like loose areolar connective tissue and dense irregular connective tissue. That's technically skin, epidermis and dermis. Now, the subcutaneous tissue is not technically part of skin. Like, it's deeper tissue, like the hypodermis, subcutaneous tissue. It's not technically part of skin, but it is attached to skin through like fibers and stuff. And subcutaneous tissue is primarily made of adipose, just mostly fat. And we also call this superficial fascia. So superficial fascia is sort of a lot of connective tissue fibers that help link skin to underlying structure, like muscle and bone. Okay? So that's the subcutaneous tissue there. Now, it can have varying thickness. Obviously, the subcutaneous tissue on your scalp is really, really thin, right? In fact, it's almost difficult to even pull on your scalp skin. It's not loose. It's not loose at all. And it's really thin. Like, you know, if you feel the skin of your scalp, it feels like there's just bone there, right? Which means, first of all, that skin's very thin. And the subcutaneous tissue that's deep to that skin is also very thin, right? Unless you have like a fatty scalp. But I don't think that really exists. I got one more thing too, guys. Leather, right? That's cow skin. So there's two types of leather, right? You got the kind of shiny type of leather, then you got the suede side, right? Well, the shiny side of leather is the epidermis. The suede side of leather is the dermis, right? And what is suede? Well, it's kind of like a fibery, soft material. Well, it kind of makes sense if you think about it, that's the dermis, because the dermis is made of a lot of connective tissue that has a lot of fibers within it. So when they make suede, basically they take cow skin, flip it over, right? You got the dermis side, then you cure it with other things, and they kind of rough it up. So it breaks the connective tissue fibers, and what you end up with then are just like the soft little suede, fibery side of the cow skin. That's the dermis. So it's kind of interesting. Otherwise, if it's like the shiny, leathery side, that's the epidermis. But where's the hair, right? Do cows have any non-hairy skin? Not that I know of. Maybe on their lips or something. But they don't have like palms. They just have hooves, right? So they must have removed that hair from like the epidermis side, if that makes sense. I don't know how to do that, but there's some sort of method. Like hair removing tools, yeah. This is showing that cube of skin. You guys, guess what? This looks just like that model we saw in lab, right? So let's go through these layers then. So we have the most superficial layer, which is the epidermis. Good, right? So all this is epidermis. What's epidermis made of? Nice. Keratinized, stratified, squamous epithelium. Good. And then all of this deeper right here, guys. This is all dermis. Two main layers of dermis. Papillary layer and the reticular layer. Papillary layer, apparently these look like little nipples. Hence these are called the papilla. So that's why it's called the papillary layer. What kind of tissue makes up the papillary layer? Loose. No, loose. Areolar connective tissue. Good. So loose areolar connective tissue. It makes sense you'd find loose areolar connective tissue here because it's got a lot of ground substance. We learned in chapter 4 that loose areolar was a good nourishing type of connective tissue because its ground substance was so abundant that gelatinous ground substance can help dissolve nutrients and bring those nutrients to the epidermis, right? So that's papillary layer is made of loose areolar connective tissue. And then the reticular layer, dense irregular. You got it. So it's that dense irregular connective tissue that is the suede, right? The suede side of leather. I know it's kind of weird because we're talking about human skin, but you guys know what I'm talking about, right? Like in terms of cow skin. Like the suede side is the dense irregular connective tissue. Now deep to that we find subcutaneous tissue. And so the subcutaneous tissue is mostly adipose. Is subcutaneous tissue part of skin? No. But we just talk about it with skin because it happens to be nearby, so why not? It's a good time to talk about it. You find a lot of skin appendages. So there you have hair, you have different specialized nerve endings, you have lots of blood vessels and muscle in here, and sweat glands and oil glands, and we'll talk about that later. Another type of skin appendage that's not shown here is also nails. So we'll talk about how nails form, and it turns out hair and nails form in a very similar manner. So it's kind of interesting. So now with the epidermis, we got several different layers here. Now we see if there's hair, we know that this is thin skin, right? So if there's hair present, it must be thin skin. And with thin skin, we got the stratum germinativum right here. It's a single layer of actively mitotic stem cells. Then you got stratum spinosum just above it. These are the cells that had been divided from stratum germinativum. And the stratum spinosum is when keratinization kind of starts to begin. You start making a lot of pre-keratin. Then we have stratum granulosum. So stratum granulosum is when the keratin starts to kind of aggregate in these granules. And that's why it has a granular appearance, hence the word granulosum. But what we don't have, though, is a lucidum, right? There is no stratum lucidum in thin skin or hairy skin. Instead, we go straight from stratum granulosum to stratum corneum. And by the time these cells get to stratum corneum, they're essentially dead. Like, these are dead cells. There's no nucleus, there's no organelles, and these cells aren't living. They're basically just big old bags of keratin, right? So stratum corneum cells aren't really a living cell. It's just dead cells that are really tough. That's what your stratum corneum is. So it's kind of interesting. But stratum corneum is the thickest of your epidermal layers. And so yeah, you can have many different layers of stratum corneum here. Now, in the dermis, we'll talk about more skin appendages later. So we'll get into some more detail on the sebaceous glands and the sweat glands and different nerve endings. So epidermis we talked about was the epithelium of skin. It's avascular, made of keratinized stratified squamous. It's got several different layers or strata. So when we say the stratum germinativum, stratum just means layer, right? Like if you guys study geology, you learn about like the geological strata of Earth because there's layers in Earth, right? In fact, we are on the crust of Earth, but there's many different layers. Just like if you looked at skin, the corneum would be like the crust of your skin. It's kind of weird to think about, but now the epidermis is made of several different cell types. We got keratinocytes, melanocytes, and dendritic cells and tactile cells. The most abundant cell type in skin is the keratinocyte. And it makes sense because these keratinocytes, they're the ones that make keratin. And they pack their cells full of keratin. And these cells eventually get pushed more superficially in skin. And eventually, as they get more superficial, they undergo a process known as apoptosis, which is programmed cell death. And these cells eventually basically kill themselves. And so you end up having like basically just a nice layer of dead skin cells. That's more superficial. So it's weird to me, right? It's weird that the outer surface of your body is actually made of dead tissue. And you look at somebody and go, oh, they got healthy skin. Like it looks like you're glowing, like so alive, right? Basically, those cells are dead. Yeah, your dead skin cells look really healthy. Yeah. So these keratinocytes make up most of the epidermis, you guys. They're tightly connected by desmosomes. We learned in chapter 2 that desmosomes are, or chapter 4, right, in tissues, that desmosomes were the type of intercellular junctions that hold cells really tightly together. And that makes sense because we want our skin to be tough. Like you wouldn't want your skin cells to be loose because if you did and you picked up on your skin, it could just tear away from your body. So these desmosomes play a very important role in holding these keratinocytes together. Another type of cell you find in skin are the melanocytes. Melanocytes make melanin. You only find melanocytes in the stratum germinativum or stratum basale. And melanin is this pigment that your skin cells will make that acts as a natural sunscreen. Okay? Because what happens is melanin does a really good job of absorbing UV radiation, UV light. Okay? And it's melanin that actually is what contributes to skin color. There's actually different forms of melanin. Like, you know how people can have different shades of skin? Like, apparently I've got like more like olive colored skin, which is weird. Like, how is skin kind of greenish, right? And there can be different shades. Like, skin can be kind of more yellowish or orangish or more brown, and there's different shades of brown. So it's actually kind of cool. So we'll talk about the different things that contribute to skin color. And it turns out, you guys, that everyone has the same number of melanocytes. Like, if you took a skin biopsy of people with different skin shades, everyone has the same number of melanocytes. What differs then is the activity of those melanocytes. Like, how active those melanocytes. If they're making a lot of melanin, then your skin's going to be darker. If they make less melanin, then your skin's going to be lighter, right? But we know that sunlight can, if you're exposed to a lot of sunlight, that can change the activity of these cells, right? That's what a tan is. So getting a tan would be like when you're out in sun, these melanocytes can somehow sense that. I don't know how they do it specifically, but they can actually start to make more melanin, which makes your skin darker, which is a natural type of sunscreen. So your body can make its own sunscreen, which is pretty cool. But I wouldn't rely on it, right? Don't rely on melanin as like, oh, you're like, I'm wearing my sunscreen. You're like, I got melanin, right? Don't do that. Don't do that. Especially in Colorado, where we're exposed to a lot more UV radiation because we're higher up and there's less atmosphere between us and space, right? Versus at sea level. There's a lot more atmosphere between at sea level and space versus up in the mountains or, at mile high and in space. So we're exposed to a lot more radiation here. In fact, Colorado has one of the highest rates of skin cancer, which you would almost expect not to be true because you think, okay, why not like Florida, right? Or maybe other sunnier states like Arizona, Southern California, where people are like in the sun all the time. They wear less clothing. You're right. It's not the fact that there's more sun. It's the amount of radiation. So I know that Denver's a really sunny state, right? We get a lot of, Denver's some state. But you guys know what I mean. Denver's a really sunny city. We could just get a lot of UV radiation here, though. It's more intense. And that's one of the things I noticed when I first moved here is I can only be out in the sun for like 10 minutes before I get sunburned. Or like I can feel it. Like I can feel it burning my skin, right? I can be out in the sun all day at sea level and not get burned, which is just weird to me. So it's just something to keep in mind. But wear sunscreen, right? Everyone wears sunscreen. Now, what are these dendritic cells? Well, the dendritic cells we also call these the Langerhans cells. I guess it's just somebody named Langerhans who discovered these things. And I love the word Langerhans, right? Yeah, I know, right? The Langerhans cells. They're also called dendritic cells. And they're basically, it's a type of immune cell. And these things can actually kind of walk around inside your epidermis. And what they do is when they walk around inside your epidermis, they basically look around and they scavenge for any kind of debris or potentially infectious microorganisms that may have made it deep into your epidermis.
That's not disturbing at all.
I know, right? So in your skin, you have immune cells that can walk around in the inside and look around for infection. Actually, I think it's pretty cool because they're helping to protect against infection. And it's almost right away. Think about this. You're not going to find the dendritic cells like in the cornea, because those are dead cells, right? You're going to find the Langerhans cells more like in the stratum spinosum, because they're going to help look around for any debris that may have slipped through, any cracks in the skin, or any kind of microorganisms that may have slipped through the cracks. Yes?
Was that the kind of cell that you showed us the video of it chasing?
Something like that. Now, I don't know what that cell type is in that video. It's kind of hard to tell just from a picture. But that could be a dendritic cell, where it's sort of chasing a bacterium, right? It had that sort of undulatory movement. It can kind of chase the bacterium. So that's going on in your skin right now. It's kind of crazy. So if you say your skin's crawling, well, it kind of is, because there's cells in there moving around. All right? Tactile cells, also called Merkel cells. That also reminds me of Germany, because the German Chancellor, Angela Merkel, right? But the tactile cells are the ones that are involved with touch. So even in skin, you guys, there are specialized cells that can respond to touch. Once they're activated, they can release chemical neurotransmitters onto nerve fibers, which take information to your brain, and you think, oh, I feel that there's an ant on my arm, right? Something like that. Or a mosquito on my neck skin. You can feel it. You can feel it land, right? So it's kind of interesting that there's actually a specialized cell type that's involved with touch. What was your question?
Can you stop talking about bugs?
All right, guys. So with the strata or layers of skin, remember, we can have 5 layers, but only thick skin's got 5 layers, right? So the 5 layers of skin, we got stratum germinativum, stratum spinosum, stratum granulosum, lucidum, and corneum. And so the mnemonic I like to use is good skin gets love and care. Or best skin gets love and care. Either works, just depending on what word you want to use, right? So stratum germinativum, like germinating layer, that would make sense for the good skin gets love and care. Or stratum basale, like the basal layer, makes sense for the best skin gets love and care. And this is going from deep to superficial. So stratum basale, or germinativum, is the deepest of your epidermal layers. It's a single row of actively mitotic stem cells. These cells are constantly dividing. In fact, these cells divide so quickly, you guys, you have a new epidermis every 2 months. So if you think about yourself 2 months ago, you had a different epidermis then, which is pretty crazy. That's how fast you replace your skin cells. In fact, the average human sheds 8 pounds of epidermis every year. 8 pounds of epidermis. That's a dry weight, by the way. Like, these are dry, dead cells. So 8 pounds of a dry, dead cells, that's a lot of skin, right? I know, right? So where do you guys think a lot of that ends up?
Your sheets.
Yeah, in your bed.
On your clothes.
They say mattresses actually gain weight because they absorb our excretions and stuff. Yeah.
And then if you're like have a husband or a wife, and then so both of you guys,
Yeah, right?
that's sick.
Double whammy. I know. Another reason not to buy a bed off Craigslist, exactly.
It's actually illegal to sell mattresses, to sell used mattresses.
Is it really?
Mhm.
I didn't know that.
It's illegal? Yeah. It's a health thing.
So stratum spinosum, you guys, is then more superficial than basale. This one still has living cells, though. So in stratum spinosum, you can still find living cells. This is where those dendritic cells like to hang out. So they walk around the stratum spinosum layer, and they're going to look for debris or pathogens that may have made it deeper into skin. Now, you still find living keratinocytes in stratum spinosum, but within stratum spinosum, these cells are starting to make keratin, we call pre-keratin, and they're using their cellular energy to make an abundant amount of this protein. Okay, so the cells are starting to prepare for apoptosis, or programmed cell death. And stratum granulosum is when those pre-keratin can be converted to what we call keratohyalin granules, and it gives these cells kind of a granular appearance, almost like these cells are full of sand. It's not sand, though. They're basically just protein aggregations of keratin. Okay, and by the time these cells get to stratum granulosum, you guys, they're already starting to prepare for apoptosis, or programmed cell death. So the nucleus is starting to break down, the organelles are starting to break down, and these cells are just really starting to pack themselves full of this protein, right? The keratin protein. In lucidum, these cells are now dead, okay? In fact, in lucidum, these cells are kind of clear, hence the word lucid, okay? And the reason why they're clear is they're full of a different type of molecule called eludin, which looks kind of clearish, if that makes sense. Now, stratum corneum are basically it's the most superficial layer of epidermis, and it's a thick layer of dead keratinocytes that are really tightly held together by what? Desmosomes. Good, very good. And these cells are chock full of keratin. So what's the function of keratin? It's waterproofing, and it's also strong. You got it. So waterproofs our skin, also makes our skin strong. In fact, I think we talked about this earlier, guys, but it's a misconception that we become pruny because of water exchange across skin, right? That is not the case. Like when you jump into a pool and you're in there for a little while, you don't become pruny because you're absorbing water or losing water into or out of the pool. You actually prune due to a nervous system reflex. It has nothing to do with water loss or gain, although we used to think that way. But the way this was determined is if you put radioactive isotopes and see if anyone absorbs those radioactive isotopes, what you find is that you don't. There's no water exchange across skin. So we've kind of debunked that. In fact, there are some cases where people are they're always pruny, even if they're not in water, because they have some sort of form of nervous system damage that they stay pruned, right? And I've read this. I've never had a chance to experiment myself, but I'd like to try it. Is apparently if you put one hand in water and you leave it there, both hands will prune. I know. So I challenge you guys to try this if you get some time, right? Don't fall asleep with your hand in that water. Yes, Ken.
So in the stratum basale layers, new cells are formed, and as they move up, it's only when they get to spinosum layer that keratin starts being produced?
Yes, exactly. In fact, stratum basale are really just actively dividing stem cells, but one of those stem cells stays behind, the other one gets pushed up. So what this means is our skin's kind of growing outward, but why doesn't our skin get indefinitely thick?
Because
It sheds off, right? It sort of sloughs off. In fact, if you look at skin underneath a microscope, you see it kind of, there's like, it comes off in big flakes. Like if you look at skin underneath an electron microscope, there's these big sort of chips or flakes of skin that eventually peel away. Because those cells are dead, right? They can't repair themselves. And our skin is kind of taking a beating over the course of a day, right? You know, we're wearing clothes, it's rubbing up against our skin, we bump into things, and so it's, you know, it needs to accommodate for that stress, and so the sloughing of skin just occurs as a natural consequence of us using our skin. It's kind of interesting. Do you have a question?
Yo, I was just saying when the keratin goes up, is it keratinocytes or keratinocytes or?
Yeah, you
and
find.
then it becomes something else like a stone.
No. These are all keratinocytes you can find in every single layer. It's just that when keratinocytes divide, the daughter cell, like the one that gets pushed up, as the daughter cell moves into spinosum, granulosum, lucidum, corneum, it starts to undergo changes. Now, it's still considered a keratinocyte. It's just that it changes into a dead cell, right? So, what do the keratinocytes look like in stratum spinosum? Anything significant about their appearance? Yeah, they're kind of spiny, right? That's why it's called stratum spinosum. In fact, these cells are still living, and because they're living, they can still make a lot of protein. Okay. Why is it called stratum granulosum? They take on a granular appearance. You got it. And those granules are made of keratin. Good. And then stratum lucidum. Why is it called lucidum? It's kind of clearish, exactly. And you only find lucidum in
thick skin.
thick skin. How about stratum corneum?
Everywhere. I mean, it's
Good, thick and thin skin. And what's it made of? Dead keratinocytes. Now we call them dead because what do they lack? They don't have a nucleus. They don't have organelles, exactly. In fact, these cells don't undergo metabolism. Like they're not making ATP and they're not trying to like maintain any processes. They're just basically a big old bag of keratin. So it's kind of interesting.
So I'm still not sure then keratinocytes are produced in the basale layer?
Yeah.
And so and then when they move up into the spinosum layer, then what's the difference between?
They start to divide.
Right? They divide in the basale layer.
Let's look at a picture. But let's talk about this one more time. So in the stratum basale, you've got a single layer of actively dividing stem cells, and these are the ones that are adjacent to the dermis. So they're closest to the nutrient supply, right? Because epidermis is epithelium, which is avascular, and it makes sense that the stem cells in the basale or germinativum, they're closest to the nutrient supply, and they're going to need the most nutrients because they're the ones that are dividing rapidly, okay, or making melanin, that kind of stuff. So in stratum basale, you're going to find keratinocytes. They're most abundant. You're going to find melanocytes, which make melanin, which helps protect against UV. You might wonder why protect against UV? Well, ultraviolet radiation is high energy radiation, and it has the ability to like make and break bonds in your cell. And you might think, oh, whatever, then your cell can just repair those chemical bonds, right? Well, if it does that to DNA, that can lead to mutations, which can either kill the cell or lead to cancer. So that's why it's so important to try to minimize your exposure to UV, because that can lead to cancer. In fact, you know, there's so many correlations of like tanning beds and cancer, you guys. I'm just surprised that these tanning beds are still legal. It's like the smoking of our generation, right? People go to the tanning bed. I'm going to the tanning bed and want to look healthy. Well, you're basically like inducing skin damage to make yourself look tanner and make your skin look healthier. And what I read online today to you guys, there's some research out of CU Anschutz, like the medical campus here. What they're finding is that there's also an association between tanning bed use and drug addiction. Because the whole idea that, you know, you get addicted to tanning also correlates with the same personality type of people who have substance abuse.
Couldn't you say that with coffee though? Like,
yeah, potentially. But I'm not just picking on tanning beds here. Like, I'm just saying that this study found that there's a correlation between tanning bed use and substance abuse. So it's interesting. Yeah. You could say that with coffee too. Certain addictive personalities. Yes.
Get vitamin D from a tanning bed, or is that artificial?
So we know that our skin can make vitamin D. And you can induce vitamin D synthesis by, being in a tanning bed. Now, what's unfortunate, you guys, is that there's no age limits on tanning beds, and there's some legislation now in Colorado to ban tanning beds for anyone less than 18, because what dermatologists are seeing now are kids with melanoma. And melanoma is the most vigorous form of skin cancer. It's the most fatal form of skin cancer. So all of a sudden you see tanning bed use going up, melanoma rates going up in children. So it's ridiculous, you guys. And so we're going to see a big change. If you work at a tanning bed place, maybe start planning to get a new job. So we had a question earlier about what does it sort of look like and how do the cells move up? Well, what this slide shows are the layers you find in epidermis. So what's the deepest epidermal layer? Stratum basale, right? Or stratum germinativum. What's this one? It's not the same thing. They're spelled differently, actually. Basal is B-A-S-A-L. So stratum basale or stratum germinativum. How about this one? Stratum spinosum, because apparently these cells kind of take on a spiny appearance. You guys see these little rivets that kind of look like they're holding the cells together? What are those things? You got it, desmosomes. Good. And then we got our melanocytes in stratum basale. We got our tactile or Merkel cells in stratum basale as well. And then this one here, you guys, is a dendritic cell. What's the function of these dendritic cells?
Immune defense.
Immune defense. You got it. So these dendritic cells are like basically mobile macrophages, and they can engulf and remove any debris from skin. Okay.
Why is there only one melanocyte or melanocyte?
Why is there only one in this picture? Or
Yeah, like, oh, that's just how they look.
what?
I don't know what I'm asking. Never mind.
Okay. The reason why there's less melanocytes in the stratum basale is there's just a less abundant cell type. Like the most abundant cell type you find in skin is the keratinocyte. But there's actually two shown here. But the point of this is that it's not as though every little patch of skin only has one melanocyte. It's just trying to show that they're less abundant than the keratinocytes. Now what's interesting then is these melanocytes, they make melanin. You might wonder, well, if melanin's made by the melanocytes which are deep in skin, how is it that superficial skin layers can still look dark, right? Well, what's interesting then is these melanocytes have these little processes that stick out, and they basically will inject melanin into the growing keratinocytes that are being pushed up. So as the keratinocytes are developing and moving upward, they start to get melanin kind of injected into those cells, so that the stratum corneum cells don't just have keratin, they also have melanin inside of them. But the melanin got into these dead keratinocytes in the corneum because back here, the melanocytes kind of put melanin into those growing keratinocytes. So it's pretty cool. So it's like cellular transfer of the melanin. Now, this one here, you guys, is stratum granulosum. And by the time these cells get to stratum granulosum, they start to get more flat. And these cells kind of flatten because they're starting to undergo apoptosis. The nucleus starts to break down here. Organelles start to break down. And they take on a granular appearance because pre-keratin is turned into keratin. Okay? Once you get all these little protein aggregations of keratin, that's why these cells start to look more granular, if that makes sense. Then we have stratum lucidum, which is more of a clearish layer, and stratum corneum, which is a thicker layer of just dead keratinocytes. In fact, if you look up here in the most superficial layers, there's not even like distinguishable cells. It's basically just like sheets of keratin, if that makes sense. And this kind of gets peeled away over time. And that's why our skin doesn't get like indefinitely thick, right? Eventually, as the skin starts to expand upward and more superficially, other layers of corneum start to just slough off, right? And the average human being, 8 pounds of that stuff every year. So that's pretty sick, yeah. So now you guys know what dust is. Like dust in the house, a lot of that, it's not just like, dirt. A lot of that's also stratum corneum. So, it's interesting. Stratum spinosum, you guys, is several cell layers thick. You got the daughter cells from the basale. They are non-dividing cells, but they're basically keratinocytes. In stratum spinosum, you also find the dendritic cells. Why might you not find dendritic cells like in the granulosum or lucidum or corneum? You got it. They're too far from the nutrient supply, right? Where's the nutrient supply for epidermis? The dermis, right? The papillary layer of dermis. Well, as these layers get more and more superficial, you're getting farther and farther and farther away from the nutrient supply, which means these cells can't really persist very well. And so due to the fact that these dendritic cells need nutrients to function, they can't get much farther away from the dermis. So they need to hang out as far as like the stratum spinosum, not much farther. If they get closer to the granulosum or lucem or corneum, there aren't really nutrients there for them to survive. Okay? And you could make the argument that if it gets closer to corneum, well, then it's kind of exposed to oxygen, right? Because the outside of our body's oxygen. Well, these cells need more than just oxygen to live. So just something to keep in mind.
Why can't it be in the basal cell?
They can.
Oh.
Yeah, they can. Actually, what's cool about these dendritic cells is they can move through the basale, either back deep into the dermis, or from the dermis through the basale into the spinosum. So they're more mobile. They can migrate back and forth. What's also neat about these dendritic cells, you guys, is that they're a type of cell called an antigen-presenting cell. When they engulf something, they digest it up into little bits. Then the dendritic cell puts those bits on its cell surface, like it puts the proteins in its cell membrane, and then it walks over to a lymph node, right? Eventually gets to a lymph node, and it basically shows other immune cells like, hey, look what I caught, right? Watch out for that thing. It's showing what it caught to other immune cells. So it helps activate the whole immune system once it actually engulfs and digests something. So like, let's say if it encountered something like Staph aureus bacterium. It can engulf and break down that Staph aureus bacterium, take proteins from that bacterium, put those bacterial proteins on the dendritic cell's surface. Then that dendritic cell can like wear what it caught like a coat. Like, look what I caught. Yeah, right? It walks over to a lymph node, shows off what it caught to other immune cells, and those immune cells can then start to also mount a potential immune response to that infection. Potential infection. I know, it's pretty awesome. So that's one of the functions of those dendritic cells. Now, granulosum, you got 3 to 5 layers of keratinocytes. Cytoplasm starts to fill with these keratin filaments. Organelles start to degrade, right? So including the nucleus. So at this point, the cell's starting to undergo a form of programmed cell death called apoptosis. And these extracellular lipids form an epidermal water barrier, and you find fully keratinized cells that are dead but strong. Okay, so you got a lot of keratin inside these cells. So basically, it's just big old bags of keratin. Now, stratum lucidum you only find in thick skin. It's more of a translucent region, and these cells lack organelles. They're filled with elidin, which is a transparent kind of protein keratin product. And then stratum corneum, it's the most superficial layer of the epidermis. It's going to be 20 to 30 cell layers thick, mostly dead keratinocytes, and it's sloughed off by abrasion. This is why, if someone wants to have, I suppose, healthier looking skin, you can do like microdermabrasion. And they sell these products like for your face, like the little devices you can like on your face and it'll like kind of scrape off the dead skin. Because by having less dead skin on there, it might look more smooth, if that makes sense, as a whole, right? Otherwise, if it's not sloughed off by abrasion, it can start to accumulate and you might get like kind of odd looking creases and that kind of stuff on your skin. So it's one way to sort of look healthier and younger, I suppose. Now, thick versus thin skin, you guys. Where do you find thick skin again?
On the hands, the palms of your feet, and the soles of your feet.
Good. Palms, soles of your feet. Anywhere else?
No.
Lips and nipples. Good. How about thin skin?
Everywhere.
Everywhere else, right? We call thin skin hairy skin. Even if you think it's not hairy, it looks like there's no hair, there is. It's just very, very small hairs called vellus hair. Vellus hair is like peach fuzz, right? Like baby hair. And that's thin skin. So thin skin is different from thick because it lacks that stratum lucidum.